Alright, it's time for some example. So in physics, displacement is a vector that quantifies how an object changes its position, let's say from point A to point B, like this. So this lady is observing an object changing its position from A to the next point B, like this. And the displacement is a vector that connects point A to point B, where the head of that displacement vector is at point B. So let's call it delta RBA. This lady can also observe point A and point B and where they are. And she can describe them in terms of position vectors, as you can see here. So in terms of position vector RA and RB, the displacement vector can be defined like this. So the displacement delta RBA is equal to RB minus RA. RB represents the new position of the object, and RA is the previous position of the object. So displacement is new position minus old position. So as you can see here, delta RBA starts with RB minus RA. Therefore, the head of delta RBA is always at RB. Let's recap what we have learned in the previous video. So what I did here is I just copy this triangle with the vectors over here, and this is how I do it. This method is connecting tail to tail, and then I draw from the second head to the first head like this. Again, if you do this technique, the head of the subtraction always goes with the first vector that comes in the subtraction. What I'm going to do next here is I copy the same triangle, but I'm absorbing the minus sign into RA. And when I did that, what I need to do is I flip the arrow. Instead of the arrow being here, it's now being there. And when I do this, I'm treating the whole thing as an addition, right? And essentially what you already have here is that I have already connected a tail of RB to the head of minus RA. And if you remember, this is how we do vector addition, right? So you have this, you have them connected properly. The resultant is you have to draw from the tail to the head. And as you can see here, it's already there. So this shows that this technique, when you attach the tail to tail together, or this technique when you absorb a minus sign into a vector, you have the same result. To enforce your learning, write, comment or share what you have learned today and hashtag PhysicsLitUp. And subscribe to Physics Lit Up for the next video.